In this video, I will explain the first circuit in our diode lab, that is the 9th lab in the series that we've been following, and it clips an incoming waveform, in this case a sine wave, so that part of it is completely missing. And this is very useful for distortion effects. So let's look at the circuit. It's very simple. We have a current limiting 1 kilo ohm resistor right here, and we have our diode. And the diode is where we're going to focus our attention on for the remainder of the video. So as we know, a diode is polarized, meaning that it will allow current to flow only one direction through it. And this is an important and useful characteristic of a diode, which means that it can be used to send parts of a signal we don't want to ground and pass the parts that we do want into our output. And that is exactly what is happening here. So let's first look at the original wave. It's a simple sine wave, about as pure as you can get, no overtones, no extra harmonics. And here is the resulting wave. So you will notice that the bottom parts perfectly coincide, but the top is almost entirely cut off, with the exception of this small 0.6, 0.7 volt little bit that is needed to forward bias or turn on the diode. So the flat tops, so-called, of this waveform are not resting exactly at 0. They're slightly above. And that is a characteristic of pretty much all solid-state semiconductor devices that I know of. So again, this diode, because it allows current to flow in one direction, when such a current is present at the right voltage or above that voltage, that current will go to ground and it will not be seen on our output, which is right here, relative to ground. So that is what we get here. And again, here is the coinciding of the two waves. You can see that as I change the input voltage, the effect is pretty much the same. And as we know, the 0.6 volt, 0.7 volt-ish forward biasing condition for this diode will always remain the same no matter how much voltage we're feeding into it, which is very interesting. So the flat top of this cut-off waveform will always remain the same. And so this is the circuit as we see it in the lab. As a little bit of an extra bonus, I want to demonstrate what happens if we reverse the direction of the diode and therefore change the way that current is distributed between the output and ground. So let's do that right now. Here the diode is allowing conventional current to flow this way into ground. Let's change that. Let's flip it around. So, right like that. And now you'll notice that the wave pretty much looks like the exact opposite, and we see the top halves of the waves. Again, with the exception of a little bit of the forward biasing voltage shift that's necessary to turn this solid state component on. And so this is the resultant wave we get. Again, we can adjust the incoming source voltage and the clipping level at, I guess in this case, negative 0.6, negative 0.7 volts remains the same. And so this is a very useful circuit for distorting and thereby adding harmonics to an incoming audio signal, which can be useful for a number of applications. Thank you for watching. I hope you learned something. I certainly did in creating this, and have a good day.